Okay, here's a probability problem where I'll use the fundamental counting principle to find the number of successes and the number in the sample space. This is the dinner party problem that you might have seen. So I have Ian, Jordan, Johnny, Allie, Grayson, Dylan, and Jackson have all been invited to a dinner party. They arrive randomly and each person arrives at a different time. How many ways can they arrive? So there's part A. Part A is actually looking for the sample space. Part B says, in how many ways can Jackson arrive first and Allie arrive last? And that's going to be the number of successes for the probability question. Part C is the probability question. Find the probability that Jackson will arrive first and Allie will arrive last. Okay, they want a fraction and simplify your fraction. So let's go back to part A. If I count the number of people up here, I have 1, 2, 3, 4, 5, 6, 7 people. Ian, Jordan, Johnny, Allie, Grayson, Dylan, and Jackson. I'm going to put 7 blanks for the sample space. 1, 2, 3, 4, 5, 6, 7. And the first blank represents the first person arriving. I'll put under that P1. The second blank is the second person arriving. The third blank is the third person. The fourth blank is the fourth person. Then we got the fifth, the sixth, and the seventh. 7 people, there are 7 choices for somebody to arrive first. Well, somebody gets to the party first, so that person's already there. That leaves 6 people for the second blank. So I'll put a 6 in the second blank so that there are 6 choices for the second person to arrive. Somebody comes second. Then there are 5 people for the third blank. There are 4 people for the fourth blank. For the fifth blank, we have 3 people left to come to the party. And for the sixth blank, there are 2 people left. And finally, the last person to arrive, there is 1 way the last person arrives who's not at the party yet. So for the sample space, I have 7 times 6 times 5 times 4 times 3 times 2 times 1. Now that's 7 factorial. So you could just type in your calculator 7 factorial, or you could just go ahead and multiply that if you want to type it all in. 7 times 6 times 5 times 4 times 3 times 2 times 1, and that is 5,040. So the number of ways they can arrive is 5,040. For part B, how many ways can Jackson arrive first and Allie arrive last? Well, I'm going to put 7 blanks again. 1, 2, 3, 4, 5, 6, 7. And the first blank must be Jackson. And the last blank must be Allie. So there's only one way for Jackson to arrive first. Jackson comes first to the party. And then there's only one way for Allie to arrive last. Allie's the last one at the party. The other people coming to the party, we don't care what order they show up. So at this point, since I have Jackson and Allie already counted, that leaves 5 people left. 5 people to come to the party in the second spot. For the third spot, there are 4 because somebody came in the second spot. And then for the fourth person to the party, there are 3 people left. For the fifth person to the party, there are 2 people left. And then person number 6, there's only one choice at that point. So this really is 5 times 4 times 3 times 2 times 1, which is going to be 5 factorial. You can either use the factorial key on your calculator, or you can go ahead and multiply it, and it's either way it's going to be 120. So for part B, the answer is 120. And for part C, find the probability that Jackson arrives first and Allie arrives last, this would be my answer from part B, because part B was the number of successes for this probability problem, over the answer from part A, because part A was the number of the number in the sample space for this problem. I need to reduce this fraction. I can see I have 120 over 5,040. So I can divide both of them by 10, since they both end in a 0. And if I divide by 10, that means I can just take the 0 off. So I get 12 over 5,004. Both 504. Both 12 and 504 are even numbers, so I can reduce by 2. And I'll do 12 divided by 2 is 6, and 504 divided by 2 is 252. Now I'm looking at this again. I can reduce by 2 again. So I can say 6 divided by 2 is 3, and 252 divided by 2 is 126. At this point, can they reduce by 3? I have 3 over 3. At the top will reduce by 3 for sure. 3 divided by 3 is 1. 126, I could add the digits. 1 plus 2 plus 6 is 9. Since 9 reduces by 3, 126 will reduce by 3. And that adding the digits to see if something's reducible by 3 only works for 3. At this point, it has to be, the sum has to give you a number that you can reduce by 3. But anyway, we're reduced by 3. 126 divided by 3 is 42. 3 divided by 3 is 1. So the answer is 1 over 42 for the probability that Jackson arrives first and Allie arrives last.